Because this silica that I made the colloidal solution out of, it has its own properties. It's slightly acidic, so it caused it to change. That's why. Because there was already this stuff in there. Yeah. Yeah, you know, the first time I saw someone do that, I was like, oh my goodness, you know, be careful. And it will definitely freeze you if you handle it for too long. You can if you do it right. You may have noticed that when I was handling it, it was moving in my hand, like I don't let it sit in one place for too long, because it definitely will hurt you if you let it sit for too long in one place. It takes practice to be able to do that. I wouldn't recommend it, because if you like pick it up like this and hold it real hard, by the time you put it down, it'll hurt you. So you have to keep it moving. Yeah, yeah. Once or twice when I found out the hard way. Yeah. So. Just little spots, you know. And it hurts. It hurts to be frozen like that. It feels like a burn even though it's a freeze. Yeah. Uh-huh. Yeah, it would. Yeah, definitely would. And we're going to do that in a few minutes, but I'm going to supercharge it by using hot water. Hot water, okay. Yeah. Yep. It goes a lot faster in hot water, which I'm going to show you. Sure. I was using the action of the dry ice to do the mixing.
Oh. It's like a submarine. Can you put more dry ice in there?
I'm going to put dry ice in here because if it comes up out of this large container, it'll be kind of like, you know, coming up and bubbling over. But if it comes up out of here, it's going to go, choo, it's going to fly out. That'll be a lot more fun.
Oh yeah.
So you'll notice that my fingers are moving when I'm handling this. I'm not holding it in one place. Otherwise it will burn.
Why is it ringing?
Well, what's happening is
It's like
okay. What's happening is the dry ice right where it's meeting the glass.
it's vibrating.
It's very rapidly turning from a solid to a gas, which is called sublimation. Usually when things are solids and they're going to become gases, usually they pass into a liquid phase first. It goes, you know, solid, liquid, gas, which is melting and boiling. But in this case, dry ice does something called subliming, where it goes from a solid to a gas directly. And so what was happening was, where the CO2 touched the warm glass, a lot of gas was being made, and the gas was trying to escape out and was making the pieces of dry ice bounce up and down, and that's what you're hearing. So, over here where it's cold, it's not happening so much. But over here where it's warm, it's evaporating very quickly.
What if you left dry ice, like lots of dry ice in there, and then you just came back and you I guess punched the glass, would all the glass break since it's been frozen? Yeah. Why would you?
I didn't hear the last part of your sentence, buddy. What was it?
Would all the glass break if you just left, if you left the ice there and then you came back and tapped it, would it snap? Would the glass break?
No, it wouldn't break like that, but if you took this and plunged it into really hot water, it would break. Yeah.
Do that.
So hopefully that won't happen in this demonstration. If it does, it won't be a big deal. I'm going to be handling a lot of this, like in the lab. Sometimes I'll use a pair of tweezers, because eventually your fingers will get cold. I can find a faster way to get this stuff in here. Plan C. So you know, okay.
There's some behind you. Can I have it? What? There's some behind you.
If you were to leave this around, if you were to just leave a piece of this on the ground or whatever, and came back later, what you find is a pile of water. Because what happens is, this stuff is so cold, it's like -70 centigrade, that water from the air will condense onto it. And once it's finished evaporating, the water that's condensed onto it and freezes will melt, and you'll end up with a little pile of water. Okay. Excuse me again. Really good. So, like, if I were to try to dissolve like honey in my drink at home, you know, you put the honey in, it goes to the bottom, then you have to mix it around, right? Well, in this situation, if I were to put honey in something big like this, it never hits the bottom. It just gets entrained in the liquid, so it very easily dissolves, very quickly dissolves. If you want the water to move, yeah, you have to put the magnet inside. The magnet is always built into this part. So some of you have seen this before, right?
Yeah.
Okay. This is one of my favorite little demonstrations. Let's hope not. I think it'll be all right. This is this kind of glass is made for lab work. It's a little stronger than typical glass.
Oh, look at that fat one going down. Look at that one. Whoa, whoa.
I'm gonna move this over to the sink now.
Yes! Let's go.
No. It's shrinking.
It's like
Snail!
It's like
Snail! You're in the video!
today, just got in the video.
You just got into video.
What's up today?
All right. Does anyone have any questions about what we did today? Yes.
Try that dry ice thing. Would you have to have this spinning thing?
No, just the dry ice as it dissolves. I'll show you. It will move the water itself. It'll move the water by itself.
Buy dry ice.
See, it's kind of stirring the water because of the bubbles. Any one will do, but the hot water will make it bubble a lot faster. Yeah, they were cold. Yeah.
Where did you get your dry ice from?
You can buy it at the grocery store. Harris Teeter sells it, and up front in these little,
Those styrofoam boxes.
Oh, those
Oh, that's dry
it's
ice.
like a cooler.
Yeah, I knew that.
That's dry ice.
I thought that was normal
Yeah.
ice. I know what I'm doing.
It's created by taking carbon dioxide and compressing it really, really hard. And when that happens, heat comes off, so you have to cool it down. But eventually, the CO2 will solidify from a gas to a solid. So it's made industrially by compressing it and cooling it. Yeah.
Isn't CO2 used in airsoft guns sometimes? Like, is that literally?
Yeah. Yeah. Cartridges for airsoft guns and stuff.
What's that mixer called?
It's called a magnetic stirrer. They're really cool, aren't they? Yeah.